Today we are going to do Unit 2, Lesson 2, which is graphing linear equations. If you want to refer to the lessons from our foundation semester, you're going to want to look at video lessons all in Unit 4, lessons 6, 7, and 8. Lesson 6 was all about slope-intercept form. Lesson 7 was all about standard form. And then lesson 8 was horizontal and vertical lines. We're going to mix all three of those lessons together today in one, and then we're going to add on something a little extra at the end, and that is how to very quickly and easily find x and y intercepts. So let's start with talking about slope-intercept form. It is called slope-intercept form because the formula very clearly gives you an m, which is your slope, and a b, which is your y-intercept. The y and the x will always be there. They will stay variables. If you look down at example number 1, you can see that y equals 2x minus 4. And so you can very easily see that the slope here is 2. Now, if you remember from last semester, I want you to write your slope as a rise over a run. So if there's not a fraction here, I make it into a fraction by putting it over 1. So my slope in this case is 2, and that's where the m is up above. Okay, so that is the 2. My y-intercept is the number that should be in the very back, and in this case it's a -4. And the way that we write our y-intercept is an ordered pair, and it's 0, comma, whatever that b value is. In this case, it's a -4. And notice that this is where the y goes in an ordered pair because it's a y-intercept. So that's what we're going to be doing for each of the problems below. We're going to identify our slope and identify our y-intercept. And now we're ready to go over to steps 1 and 2. How do we graph these? Step 1 says to plot the y-intercept on the y-axis at 0, b. So my y-intercept is 0, -4. I'm going to plot that point on the y-axis at -4, and I've done step 1. Step 2 says use your slope as directions and plot more points. So let me show you how I'm going to do that. I have 2, which is a +2, over 1, which is a +1. So I will go up 2, right 1, and there's a point. Up 2, right 1, and there's a point. And you could continue that. Now, as a quick reminder from last semester, I want to just tell you that the numbers have to stay the same, but you can change the value of both the numbers. Instead of a +2, you change it to negative. Instead of a +1, you change it to negative. And remember that what that allows you to do is to change directions on your graph. In case you run out of room, you might have to do this sometimes. So instead of going up and right, I'm going to go down 2, left 1, and put a point. And how would I know if I've done this correctly? Well, all of the points should form a nice straight line, even after you've changed directions. And then just a quick review of what kind of slope is this. So let me do this in green. This slope was a +2 slope, so this is a positive slope. You could tell by looking at the equation because that's a +2, or you could tell by looking at the graph because from left to right, just like we read a book, left to right, it's going up. Okay, so from left to right, it is going up. So looking at the graph, you could also tell that it's a positive slope. or you could tell by looking at the equation. Very good. Let's try number 2 together. So my very first step is to identify what is my slope. In this case, it is a -3. I'm going to make that into a fraction, so I'm going to put it over 1. Now I can very easily see here that my slope is negative. So this is a negative slope. All right. Um, Now we could also write the slope if we change both the signs. I could make that -3 into a +3. But remember, I would also have to make this +1 into a -1. So +3 divided by -1 is still going to equal -3. So it doesn't change the value. Next, I need to identify, and that was my slope. Next, I need to identify my y-intercept. In this case, my y-intercept is a +4, and I need to be sure to write it as an ordered pair. Remember that the 4 goes in the spot where the y goes in an ordered pair. So we're going to do step 1, which is to plot the y-intercept at +4. And then we will use our slope as directions. So I could go up 3, back 1, but that's off my graph. So instead, I will go down 3, right 1, down 3, right 1. And notice after I do that, every time I make an order, or I make a point on the Cartesian plane. All right. And then, of course, you do need to connect all of your points with a nice, perfect straight line, or at least to the best of your ability. All right, now how could I tell that this slope is negative by looking at the graph? Well, still just like a book, from left to right, okay? Um, by it's, I mean the graph is going down. Okay, so from left to right, I'm moving in the downward direction. So that tells me that my slope will be negative. So 2 different ways to identify what type of slope you have. I'm going to scooch this down. I can now see examples 3 and 4. I'm going to help some of us out who might not remember. In number 4, there is no number back here. And what that means is that my y-intercept is 0. But everything else is done exactly the same. So I'd like for you to pause this video and try examples 3 and 4 on your own. All right, I have completed examples 3 and 4. And so just take a minute, check your work. It was important to be sure that I knew how to change the values, the negative or positive signs of my slope so that I could go both directions, especially in number 4. Now let's go look at number 5 together. Number 5. I would like to identify the slope in the y-intercept, but I need to do something first. You need to make sure that this is in slope-intercept form, which is y equals mx plus b. And right now there's a 2 in front of the y value. So it's not quite yet in the right form. I need to do a little bit of work. So how would I get this y by itself? It says 2 times y. I'm going to go ahead and divide both sides by the 2. And we need to divide all 3 terms by that 2. And so that will give me y equals -1x minus 3. And now that I've done that, I am now in slope-intercept form, and I can see that my slope is -1 over +1. And we could also change the signs, right? +1 over -1. Be sure to change both signs. And then I can see that my y-intercept is 0, -3. This is still a y value. So I'm going to plot that on the y-axis, and I'm going to use my slope as directions. Down one, right one, down and right. Or I could go up and left, up and left. And I'm going to connect these points with a straight line. Fantastic. Now we're looking at example 6. Example 6 is a good review from last semester. Okay, I am going to rewrite my equation so that it shows me a slope. It would look like this: y equals 0x plus 4. If you remember, this was HOI. HOI. And what did that acronym stand for? The H means it's a horizontal line. The 0 or the O means it's a zero slope. And the Y means it will cross the y-axis. So those were our notes, just to refresh us from last semester. So my slope here is 0. You could also write that as 0 over 1, okay? And then my y-intercept is a 4, so 0, comma 4, where that's my y value. So now I can do the same process. I'm going to go up 4 and plot that point, and now I'm going to do my slope. So I rise from here 0, and then I go right 1. Then I rise 0, and I go right 1. And there's points here. I rise 0, and I go right 1. And you can see if I continue, this is just going to make a nice straight horizontal line that goes directly through the y-axis, and it's never going to touch the x-axis. And so that's why we use HOI as our acronym to help us remember. All right. Let's go take a look at standard form up here. Okay, how do we graph linear equations that are in standard form? Well, just like in example 5, the very first thing that we really do need to do is put it into slope-intercept form. So I kind of jotted some notes over here. It says add and subtract the ax term. So I would subtract ax from both sides. How would that look in example number 1? Where is the ax term in example number 1? That's just ax right there. So it's a positive 4x, so I would subtract 4x from both sides. Now, both in our standard form example and in example number 1, I have a c and an ax, and then I have a constant term and an x term. And I cannot combine those. So what I will do, because they're not like terms, I'm just going to put the ax first so that it's in slope-intercept form. Put the negative 4x first so that it's in slope-intercept form. And then bring down the y term. Don't forget the negative sign in front of the 2. That's the most common mistake. All right. My last step to get the y by itself is to divide by whatever the number is in front of y, which is my b. So here it's just the letter b, and we'll divide that everywhere. So now that the y is by itself, down here in this example, I would divide by this negative 2 everywhere. And now what I just want to do is to make sure that I simplify everything. So I have y equals negative 4 divided by negative 2 is a positive 2x. Negative 6 divided by negative 2 is a positive 3. And I now have my slope-intercept form of my line. So that was all step 1 over here in green. Once I am back into slope-intercept form, I can do exactly what we were just doing on the left side of our paper. which is to identify the slope, 2 over 1, and identify the y-intercept, which is 0, comma 3, and then go ahead and graph them. So 0, comma 3 is right here. My slope of up 2 over 1 is right there. Now, if I want to do some more points, I need to do negative 2 over negative 1. A negative divided by a negative is still positive. So I would go down 2, left 1, down 2, left 1. And now I've got a few more points so I can make sure that they line up in a straight line. Great job. All right, I would like for you to practice with example number 2 on your own. So pause the video and try to put this into slope-intercept form on your own. Hopefully you were able to solve this. This is review from last semester. Some of us might need some more practice remembering than others, and that's okay. But once we're in slope-intercept form, now we're ready to graph it. And this is probably the easier part anyhow. So here's my slope, negative 3 over 2. Or you could do positive 3 over negative 2. Remember, those things are equal. And then your y-intercept is 0, negative 4. So I'm going to plot negative 4. And I can't go down 3, so I will need to use the positive 3. Oh, negative 2 should be to the left. So positive 3, left 2. Positive is up 3, left 2. And then you can do it one more time if you want to go all the way to the end. And then we connect all these points with a line. And that is example number 2. Okay, let's take a look at example number 3. Again, the first thing that I want to do is get this into slope-intercept form. So subtract my x term, and then divide by the coefficient of the y term. The coefficient, remember, is the number in front. And then I'm going to write my simplified answer out here to the left. Y equals negative 1 divided by negative 2 is 1/2. Negative 5 divided by negative 2 is a positive 5 over 2. Here my slope is 1/2, 1/2, or negative 1 over negative 2. And my y-intercept is 5/2. Now, in order to plot this, we need to understand what 5/2 is. 5/2 is the same as 2.5. So 0, comma 2.5. And that having it in a decimal form is going to help me plot the point more accurately. So on my y-axis, I would go up to 2, and then I would try to find the halfway point between 2 and 3, and that's about 2.5. It won't ever be perfect when we're graphing these by hand, but it's a good rough estimate. And now what I'm going to very carefully do is rise up 1, so from 3.5 to 4.5, and then run 2. Rise up 1, which is at 4.5 now, and run 2. Rise up 1, which is at 5.5, and run to the right 2. And that is what this line will look like if I graph it. Excellent job. Now we're ready to talk about example number 4 here, which is graphing the equation x equals 4. If I look at this equation, the first thing that I notice is that there is no y variable, and that's very important. That helps us to identify these vertical lines. So to graph x equals 4, remember from last semester our acronym VUX, V-U-X, and to help us remember what that stands for, I wrote it down here. V helps you remember that it is a vertical line. U tells me that it is an undefined slope. And then X tells me it's going to be crossing the x-axis. So when we do the M and the B here, it's going to be a little different. So my slope is going to be undefined, which means it's going to go straight up and down. My y-intercept does not exist because it will not cross the x-axis. Okay, so there's no y-intercept. So here's how I'm going to graph this. I know x equals 4, so I'm going to go on the x-axis over to 4, and I'm going to put a point. It's not blue because it's not my y-intercept. And then undefined lines go straight up and down. And that is exactly how I graph an undefined slope, or a line that looks like x equals 4. All right. Let's come down to the bottom of our paper and do these very last two examples, which are brand new for this semester. We're going to talk about how to find x and y intercepts without graphing. The x-intercept, I do want to add some notes here. We've already been looking at the y-intercept, which looks like 0, comma y. We've been using b there because b represents my y-intercept. Now for the x-intercept, it's going to look very similar, except I am going to have x, comma 0. So that's an x-intercept and a y-intercept, and that's what they look like as ordered pairs. So what this means is we will be plugging in zeros and then solving. It is good to know this method because if you look at the graphing the function in example 3, it's the exact same problem as number 1 right here. And I did that on purpose. I knew that my slope and my y-intercept for that example were both fractions, and it's not exactly sure, I can't tell exactly by looking at it, that the x-intercept is a -5. It might be if I drew it accurately, if I was doing a really good job at plotting my points, but there's no way of knowing for absolute certainty. So the only way that we can know with absolute certainty is by to find the x-axis, to find the x-intercept, I would plug in a 0 for the y value and then solve that to find the exact value where this line crosses the x-axis. So here's how I teach this. It's going to be very organized, okay? I'm going to make a table, and on the left, I'm going to find my x-intercept, and that is where the y value equals 0. And on the right, I'm going to find my y-intercept, and that is, remember, where the x will equal 0. So I am going to bring down x minus 2y equals -5. And I am going to plug in a 0 for the y. And now I'm ready to solve this. So -2 times 0 is just 0. And I have x equals -5. So the x is solved for. And now I'm going to write this as an ordered pair, -5, comma 0. And that is my x-intercept. That's all I have to do. Let's try for the y-intercept. So for the y-intercept, I put in a 0 where the x value is. All right, and so let's plug in this 0 for the x. And now I can solve. So negative 2y equals negative 5. Divide by negative 2, and I find that y equals positive 5 halves, which is, as an ordered pair, 0, comma 5 halves. And if we scroll back up and look here, we can see that we did get the y-intercept was 5 halves when we solved this equation for y equals. And it says b equals 0, comma 2.5, which is the same as 5 over 2. So we will still get the same values, but we can find the intercepts without graphing, and that's really the benefit of this. All right, so the big benefit is finding x and y intercepts without graphing. And if they happen to be fractions, we can have absolute certainty that we have the exact correct intercept value. What I'd like for you to do is practice number 2. I'm going to help you set up your table, and then I want you to try it on your own. All right, so here's our table. Go ahead and pause this video and then give number 2 a try. So I have done both the x-intercept and the y-intercept. I've solved both, and I have x equals 2 and y equals negative 4. I'm almost there, but to officially write your x or y intercepts, I need for you to put them as an ordered pair. So this should be your final answer. All right, great job. There is a practice assignment for you on Google Classroom. So go ahead and get started on that. Whatever you're not able to finish in class will be your homework.